Okay, so in this problem we have number 2. This is quiz corrections. So we have a graph that kind of looks similar to this. So we have velocity on the y and we have time on the x. We're giving the weight of the carts and we're asked, is there a change in momentum? And the answer to that is, well, no, there is none, because using the formula pi is equal to pf, conservation of momentum, we find that the variables would be m1 v1 is equal to m2 v2 plus m3 v3. Well, this is because we have to think about this as the opposite of a collision, which would be kind of an explosion, because we have two objects going in constant linear motion and then boom, they separate. So we have this one right here and this one right here. So we know that the original mass, if we want to prove it, we know that the original mass is 3 times velocity would be 2. Obviously that's 6 is equal to m2 would be this one. So 2 times 1.5 plus 2.5 is equal to 5 plus 1 times 1 is equal to 1, and boom, 6 is equal to 5 plus 1. So that's number 2. Moving on to number 3. We have 1 second for me to draw it up. Alright, so this next question is basically there's a ball with a mass of 2m heading towards an object. The object then gets hit up and then it goes up to a final point of h0, and basically it's asking us about the quantities immediately after the collision and the instant the block reaches a height of h0. So the answer that I put in was basically A. It was linear momentum. The reason it's not linear momentum or angular momentum or any other of the momentum solutions in the multiple choice thing is because it's asking us after the collision, meaning that it already happened. So the best way to describe something after that would be energy. So there's 2 answers left: total mechanical energy of the clay block system and total mechanical energy of the clay block earth system. And the correct answer is earth because it takes into account the effects of gravity, which will pull it down. And that's number 3. Number 4 is asking us for a graph. 1 second. Alright, so number 4 presents us with a graph of velocity over time. And right here we are given 2 objects that start off as separate, but once they collide, they turn into one. So it's asking us about the velocity in regards to which statement is correct. So it's very similar to this one, because all we really had to do was, we know the mass, we know the velocity, this whole area is the velocity, so we just multiply them. It's just 2 kg. So we multiply them. For example, here we have a positive velocity, so 6 times 4 is 24. 24 minus, because this is negative on this side, minus negative 3 times 2 minus 6 is equal to, this is the after the inelastic collision in which now they're together. You basically add up both masses since you know they're together, so that'd be 6 kg. You multiply these two, 18, and once you know 24 minus 6 is 18, which means that is the answer. The velocity of the center of the mass of 2 object system remains constant during the experiment, and that's the answer. And on to number 5. I also need to draw a graph for that one, so 1 second. Alright, so for this next one right here, we're given an approximate graph. It's supposed to be an approximate answer, and it's supposed to find the magnitude of change in momentum. So basically, the solution to this problem is quite simple. You just have to find the area under the graph, but because the graph is a little funky, you have to separate it into simple geometric shapes. For example, in the first one from 0 to 2, we can write it as a right triangle and just use 1/2 base times height to find it. So 10 times 2, yeah, that would be equal to 5. And then from here to here, it's the same thing, but we make it a square. 2 times 10, 20. From here to here, since we know that they're both the equal height, you can basically make it another square. That's 20 more. And then we have 5 up here because it's a triangle. But wait, the question isn't asking that. The question is asking from 0 to 4. So basically, just kind of exclude these numbers right here. This is just to like show you like more. Also because I kind of messed up. But it's okay, you know, mistakes happen and the whole point is to fix them. And so you just add these two up, 25. And since it's a whole number and we're trying to find an approximation, we basically round it off. So that's 30. And boom, baba boom, that's your answer because that's the only one that is left. On to number 6. Okie dokie, so for the last one, I only grabbed 2 points because those are the only 2 points we really need. We have, on this side we have the momentum, P, and on this side we have the time. So basically, it's asking here, a cart travels on a right track where friction friction between the cart and the track is negligible. The momentum of the cart starts as a function of time modeled in a graph in which statements are shown for the which of the following statements are true for the time recorded. Select 2 answers. So there's 2 answers to this, very important. So we know that the correct answer is B. The impulse delivered to the cart is nearly 0.7 kg times ms, and we know this because delta P is equal to J. We know that because they're both equal to each other, and using the formula, delta P is equal to Ft, which is equal to delta J, or impulse. On the formula sheet, we find that. So yeah, it's just rewrite it. And the next one is the net force of the cart is nearly 0.15 newtons, and we can find that out with the formula Ft is equal to mv, because we know mv is equal to P. So because we have P right here, we just isolate F, so mv over T, and since we know it's 5, we know, we don't really know the mass, but we know like the total P. 0.75 divided by 5 is equal to 0.15, and that gives us our final answer. Thank you for watching.